Hi, fifth graders. Happy Monday. Today is Monday, February 8th. Your learning target is I can calculate the amount of work in different situations. So today you just need your planner, pencil, and your science notebook. Now, your question of the day, if we're going to be doing this live or together, did you complete your Friday Flipgrid? So think to yourself, did you do it? Did you get it done? Please make sure that you have an answer of A or B by the end of today if you did not get it done on Friday over the weekend. That's just kind of your reminder. Please make sure you're doing your Friday work. Speaking of work, today we're going to talk a little bit about what work is in physics. Now that is going to be a little bit different than what you picture as work like in the real world, or what your parents do, or what I as a teacher do every day. Work is going to be a little bit different than that. Now, we're going to take out our science notebook, we're going to turn to a blank page, and we're going to title the page work. I'm about to switch over to the DocCam here so I can take the guided notes along with you. Alright, so I've switched over to the DocCam here. I have my blank notebook page. We are going to title this one Work. Now, like I just said, work in the world of physics and forces, and really what we've been working on lately, is a bit different than work in like going to a job. So work in physics is really when a force is exerted on an object and that object moves a distance. That is when work is being done. So work happens when a force is exerted. Remember, that kind of means like put on it. So when a force is exerted on an object and that object moves a distance. That's the key word there, and. It has to be both force and a distance. Now, the reason why it has to be the word and here is because of the equation, the mathematical equation we use to determine if work is done. Work is equal to force times distance. Now, a lot of times we can shorten this to W equals F times D. Now, this is the equation that you're going to be using today in order to calculate, that's our learning target, calculate the amount of work done. So when you are using this equation today, this is why your object has to move a distance and force is being used. Because if you multiply anything by 0, your answer is going to be 0. So that's why it has to move a distance. That's kind of a key part of today. So then let's go ahead and let's do a little example here. So let's have a person. They are holding a box. Let's say they're moving someplace. Alright. Nice little smiley face. Oh boy, their body is not connected. There we go. Fixed it. Now, this person needs to move this box a certain distance. So let's say they have to bring the box all the way over there. Okay. That distance is 10 meters. 10 m for meters. Remember, in science we used centimeters and meters. Now, that's our distance. The amount of force that we need to move that box is 5 newtons. So then we have our force and we have our distance. So we can set up our equation to figure out how much work is being done when that person moves that box from over here to over here. So we want to start with our basic equation. W equals F times D. Remember, that stands for work is equal to force times distance. Then all you need to do is plug in your numbers that you have. So work is equal to force, which is our 5 newtons, times our distance, which is 10 meters. Now, when we multiply those together, 5 times 10 is 50. Now, the unit that we use to describe the amount of work that is being done is with joules. Joules, not like the jewels that your mom might have at the house or fancy people wear. Right? This is named after a guy whose last name was Joules. So we calculate work in joules. That's just our unit. Just like distance is in meters, force is in newtons, work is done in joules. It's just a nice, easy way of saying that. So that is your equation for work. All right, now a key part of this is to make sure that it has to move a distance. If I try really hard to push this table in front of me and I'm putting like 1,000 newtons of force on it, but it doesn't move, that means I've done 0 work, because 5,000 newtons times 0 is 0. So that's why it has to both be a force and a distance. If it doesn't move, you're not actually doing any work. Even though I might be sweating trying to push this table, if it doesn't move, work isn't done. So what I need you to do now is to complete the short, sorry, I'm trying to figure out the lighting here, the short Google slides that I have for you. So it is actually in a Pear Deck. So what you're going to do is you're going to open up the Pear Deck here, and then I just have 5 questions for you for practicing. So it says calculating work, complete the following Pear Deck using what you know about work. Remember, work is equal to force times distance. So then you're going to go through and you're going to type your answer in. There's a little example on each one, so just 1 question per page, only 5 questions. So just make sure to try your best. That is your work for your homework for today. Good luck. Let me know if you have questions. Thanks. Bye.